right, today what we're going to do is we're going to start chapter 12, and we're looking and exploring solids. So the first thing we're going to do is do a couple of definitions. The first one is polyhedron. What a polyhedron is, it's a 3D figure or a three-dimensional figure whose surfaces are polygons. So if you think the difference between a two-dimensional figure and a three-dimensional figure, a two-dimensional figure, I think of one that I can't put my arms around. It's a flat surface like a square or a rectangle, very similar to the last chapter we got done with. A three-dimensional object is something that I can put my arms around, very similar to like a cube or a cone or a cylinder, something I can touch and put my hands around. Faces. The faces are the polygons of the three-dimensional figure. The edges are the segments, that is the intersection of two faces, and the vertices are the edges where they intersect. So if you take a close look at this figure, you're going to see that the faces are the flat surfaces right here. So you'll notice that this is an example of a face. It's this whole polygon here. There's a polygon here. So there's a front and a back, and a top and a bottom, and a side and a side. So in this particular one, there are 6 faces. If I take a look at edges, edges, what they are they're the lines where the two faces come together. So you're going to see there's an edge there, there's an edge here, there's one here, there's one here, there's one here, there's one here, and they go all the way around the figure. So they're on the top, on the bottom, and around the middle. A vertex, what that is that's kind of like the point. So it's where those edges and faces kind of come to a point. So a vertex is there's one there, there's one here, there's one here, and they go all around the figure where the corners, shall we say, are. So let's keep going and let's take a look at this figure. So how many faces, edges, and vertices does this polyhedron have? So if you take a look at it, and you can kind of look at it really closely, you can kind of see that it's a three-dimensional shape. But if I look at this and answer those questions, it says how many faces. So you'll notice that as it's facing you, the front of it, that's a polygon, and that's a pentagon. So the pentagon is in the front, and there's a pentagon in the back. And since that pentagon has 5 sides, that figure also has 5 sides going around the middle. So the front and the back and the 5 sides make 7. So there are 7 faces. Now, if we look at the edges, you're going to notice that there's 1, 2, 3, 4, 5. I'm sorry, vertices. I'm looking at edges. So if I look at the edges on this are those lines. So 1, 2, 3, 4, 5. So there's 5 on the front. There'd be 5 in the back. And then there'd be 5 going 1, 2, 3, 4, and 5. So 5 in the front, 5 in the back, and 5 going around the middle. That ends up giving us 15. Now let's take a look at the vertices. So remember, the vertices are those corners. So 1, 2, 3, 4, 5. And there's also 5 on the other side. So that ends up giving us 10. Now, something that students struggle with is if I'm given a three-dimensional figure, what does the net look like? So what a net is, it's a 2D pattern that you can fold to form a 3D figure. Okay, so it's kind of like taking the figure that's in front of you, cutting it like on the top right here, and cutting it like this, and then folding it open, all right? So you're gonna notice that this is blue, pink, white, cube, and pyramid. What we would do is, if you are in class, I would actually give you a blue net, a pink net, and a white net, and we would fold it up and form a three-dimensional figure. Since you are not in class, what we're going to do is I'm going to take off blue, and I'm just going to write in what the shape actually is. So the blue shape, if you were in class, is a rectangular prism. And what that means is it's like a box where I have, the top is like this and the bottom is the same thing. And then the sides are also rectangles. So the top and the bottom are rectangles. And then all the sides would also be rectangles. So you'll notice if the top is 4 sides and the bottom is 4 sides, then the middle would also have, 4 sides, whatever that looks like this. So it's asking you, if I have a rectangular prism, how many faces would I have? Well, think about a rectangular prism, the top and the bottom, and then the 4 sides around the middle. That would give us 6 faces. If I look at the vertices, okay, I've got right here, there's 1, 2, 3, 4 on the top, and then there would be 4 on the bottom, so it's a total of 8. And then if I look at the edges, I've got 1, 2, 3, 4 on the top and 4 on the bottom. And then if you think, they would go back and there would be 4 more. So there would be a total of 12 edges. And really what works the best for this is if you take like a box, a Kleenex box or something like that, and you look at it from that perspective, it makes it a little bit easier. Now let's take a look at the pink. Now it says pink, but if you were in class, I would give you a triangular prism. And what that means is the top and the bottom are triangles and the middles are rectangle. So if we look at that and just look a little bit closer, so let's say the top and the bottom are triangles. So I'm going to kind of draw a picture. And then I'm going to connect the vertices. It kind of looks like that. That's really what it looks like. Okay. And you wouldn't maybe see this part. So it would be, kind of dotted here and solid here. So anyway, the top and the bottom are triangles and the sides are rectangles. So the top and the bottom are triangles. So that would be 2 faces and then 3 around the middle for a total of 5 faces. If I look at the vertices, okay, you're going to notice that I've got 1, 2, 3 on the top and then 1, 2, 3 on the bottom. So that would be a total of 6. Okay, and then if I look at the edges, well, I've got 1, 2, 3. I'll make that better. 1, 2, 3, 4, 5, 6, and then the 6, 7, 8, and 9. So it's a total of 9 edges. Okay, now what we're going to do is take a look at the white shape. What the white shape is it's a cylinder. Okay, and what that would be like a can of soup, something like that. Okay, so if I take a look at that, how many faces? Well, again, we're not going to be looking at faces and we're not going to be looking at vertices and we're not going to be looking at edges because you'll notice that it's not a polyhedron. A cylinder is not a polyhedron. What it is the top is a circle, the bottom is a circle, and if I look at the middle, that would be a rectangle. So that is kind of a tricky one because it's not even a polyhedron. So I would do that in class and we talk a little bit about that. Now what we're going to do is we're going to look at a cube. Now when they talk about a cube, what they're looking at is like a dice. Okay, so their squares are the sides. So if I think about a dice, I've got a top and a bottom, and then I'd have 4 sides. So the total number that I would have for faces is 6. Okay, the vertices, I've got 4 on the top and 4 on the bottom for a total of 8. And then the number of edges, remember that's the flat side. So there's 4 on the top, 4 on the bottom, and 4 in the middle for a total of 12. And then finally, we're going to look at a pyramid. Now, when we look at the pyramid, I'm going to, again, it's a triangular pyramid. And so what that means is the bottom of the shape is a pyramid, and then it comes up to form, and I know this is going to be a terrible drawing of it, but let's say I have the point at the top, and if you think of it, it's like a pyramid in Egypt. So it looks something like that if you want to look at it that way. So the bottom is a face, and then you've got 3 triangular faces for a total of 4. if I look at the vertices, I have the top and then 2, 3, 4. Okay, and if I look at the edges, I got 3 on the bottom shape. So I've got 1, 2, 3, and then 4, 5, and 6 for a total of 6. Okay, now what we're gonna do is we're gonna look for a pattern on this table. And if you look really closely, what it does is it forms something called the Euler's formula. And what that says is if I take the number of faces and I add the number of vertices and I subtract 2, I'm going to get the number of edges. So let's just look at a quick example. So if I look at a rectangular prism, the very top, if I take the number of faces, which is 6, and I add the number of vertices, which is 8, and I subtract 2, that should give me the total number of edges, which is 12. And you're going to notice that it's true. If I take a look at the pink line, the triangular prism, I'm going to look at the number of faces plus the number of vertices. I'm going to subtract 2, and that gives me 9, which is the number of edges. So you're going to notice that this Euler's formula also works when we're talking about faces, vertices, and edges of polyhedrons. Now what we're going to do is it says draw a net for each figure. And I'm going to have you do this because many students, they memorize the formula and they don't really understand what the shapes are for the top and the bottom and the front and the back and the sides. They don't know how to draw them and they can't visualize them because you don't always remember the formula, but you can figure out what the shapes look like. So in the first one, if I take a look at this, I'm going to do the top and the bottom. Okay, and if you think about the top and the bottom, the top looks like that. And you're going to notice that it would be something like this, but you'll notice the dimensions are down below. So 1 would be 10 and this would be 8. And you don't have to draw the top and the bottom separate. You can go ahead, since they're the same dimension, you can do the same. Now what I'm going to do is I'm going to do the front and the back. Okay, and if I take a close look at this figure, the front and the back, it's this right here. So it's that rectangle, long and skinny, okay? The bottom of it is 8, and you're going to notice that the sides are 15. Oh, I'm sorry, it's 10, not 8. It's 10. And then if I go ahead and I do the sides, and what that is like the left and the right. It's also that shape, but you're going to look at it, it's going to have a little bit different dimensions. So when I look at this, it's going to go like this. And you'll notice I've got 8 for the bottom, and the side would be 15. So it'd be 8, and it would be 15. And you can notice that all of them have kind of the same shape, but they have different dimensions. Now let's take a look at this figure. Now this figure, it's really hard to see the bottom. So I'm going to tell you that the base, or you can call it the bottom, is a pentagon. And of course, pentagon means 5 sides. So I'm going to go ahead and I'm going to kind of draw that base like this. Okay, and I've got a 5, and then I'm going to mark it that all the sides are the same. And then I'm going to go the sides, since they are also the same dimension, they are a triangle. And this is 8, this is 8, and this is 5. And then finally, the cylinder, which we talked about on the last slide, you're going to do the base or the top and the bottom. I don't really care. Okay, that is a circle, and you're going to notice that this tells you the diameter of the circle, which is 10. And then you would write the middle, and a lot of students don't realize, but the middle part of it is like this part right here, and it's kind of like a Campbell's soup label. You cut it and then you open it up, and actually it is a rectangle. And to find the dimension of that, this is 20. So if you look at it, they give it to you. But if I look at this dimension right here, what this is the circumference of the circle, the distance from here to here. And if you think about it and actually look at a can, you're going to see that it does come all the way around and form the circumference. Let's move on and let's name some of the 3D figures that we have here. So again, you look at the base of the figure when you're naming it. So if I look at this figure, I'm going to take a look at this, and this is going to be my base. You're going to notice it's a triangle, so it's triangular. And you're going to notice that the sides are triangles and they come to a point, so this would be a pyramid. This shape right here, if you take a look at it, now, some students will say the base is this right here because that's what it sits on, but actually that is not the base of this figure. You'll notice that the sides are rectangles, but the base is actually this. So when you have two of the shapes that are different from all of the sides, the two shapes that are different, name the base. So this would be a pentagonal, and this would be prism. It's a prism because the sides are rectangles and the top and the bottom are pentagons. It just isn't sitting on its base, it's sitting on its side. And let's take a look at this. You're going to notice that the sides are triangles, and if you look at this piece right here, that actually tells the base. So this one is a pentagonal, and it would be pyramid. It's a pyramid because the sides are triangles and then the bottom is a different shape. In the past one, it was a triangle. Notice the first one was triangle, but this one's actually a pentagon. When I look at this one, you're going to notice that I've got triangles, and you're going to notice that then this is the base of it. This would be a rectangular pyramid. So pyramids, you're going to notice, have triangles for the sides. This shape, you're going to notice that you have a combination of rectangles and a combinations of triangles. You're going to notice that it's actually resting right now on its base. This is a triangle. So I'm going to say triangular. And it's a prism because prisms have rectangles for their sides. And then finally this one, this side looks like it could be a square, but unless it gives you the dimensions that says it is a square, you cannot assume that. So on this one, I would call this a rectangular prism. And that is it for 9-1. If you have any questions, please let me know. I'll be happy to answer them.